All right, this is video 9 for geometry. Today we're going to be talking about properties of parallel and perpendicular lines. And with geometry, we've got a lot of vocab that we have to learn with this because it's a little bit different than algebra. So first of all, a line that intersects two coplanar lines at two different points is called a transversal. Okay, and so line T is a transversal. Okay, the next one, corresponding angles. So corresponding angles lie on the same side of the transversal and the same side of lines R and S. Okay, so for example, angle 2 and angle 5 are corresponding angles, okay? So we'll make those in red. They're at the same spot of both of those lines. All right, the next one would be alternate interior angles. Alternate meaning opposite, interior meaning it's between the two two lines. So something that's an alternate interior angle could be 1 and 6. Another alternate interior angle would be 4 and 5, but those are the only two alternate interior angles that we have. Okay, the next one would be alternate exterior. Okay, and those lie on opposite sides of the transversal outside of R and S. Okay, so opposite sides of the transversal, outside of R and S. So for that, we could have, let's go ahead and say 3 and 8. So angle 3 and angle 8. Now there are lots of different alternate exterior, there's lots of different examples for corresponding angles and alternate interior angles and alternate exterior angles. I just gave you one example. All right, and the next one is parallel lines. Remember, those are coplanar, but they do not intersect. And how we could write that is I could say LM is parallel to PQ. Okay, and so lots of times we just like to write those two lines to show that something is parallel. All right, so now looking at our parallel lines conjuncture. If two parallel lines are cut by a transversal, then the corresponding alternate interior and alternate exterior angles are congruent. So we're going to simplify this a little bit. That's a lot of words. So in our angles, we have big angles and small angles, okay? Small angles, big angles. The big angles are going to be congruent. The small angles are going to be congruent. Same over here. We've got big, small, big and small. So 2 and 7 are congruent because those two are both the same small angle. Okay, so we can put a whole bunch of vocabulary and put a lot to it, but this is the gist of it, okay? All the stuff that we do in here, all this stuff adds up to 180. So no matter where, your BS is gonna add up to 180. So here we've got SB adding up to 180, SB again, 180. Okay, and so those are just, our parallel lines conjuncture is just a fancy way of saying our angles are gonna be congruent. All right, so moving on, we've got the same side interior angle postulate. So what this means is angles that lie on the transversal inside of the parallel lines are supplementary, okay? And that's what we just talked about. So I could say angle, let's go ahead and say 5 and 6. 5 and 6 add up to 180. I could also say 5 and 7 add up to 180. 7 and 8 add up to 180. Okay, so we've got a lot of lines that will add up to 180 here. All right, and let's find all of the sides here, okay? And this should be given. One of these is 60 degrees. Okay, when we're given a shape and we have to find out the measure, this is a parallelogram. I like to extend my lines as if they were parallel lines. Okay, so this, I like to extend this so it looks like how I'm used to seeing it. Okay, where I've got lines cut in half by a transversal. And that way, it just helps me see a little bit better. Okay. And so from our same side interior angles, we could actually also have 5 and 3 being that. And so let's actually change that to 3, just for our example. All right, so here we've got our angle. So if I know from that same side interior angle, these two should measure up and be the same, they should add up to 180. Okay, so 180 minus 60 is 120. Again, 180 minus 120, here this would be 60. 120, okay? There's lots of ways we can find this, but that's one of the easier ways. All right, so now we've got some practice, and we just have to figure out what are some of these examples. So if we're looking at this, okay, we're trying to figure out what types of angles are these. So 1 and 5. 1 and 5 are on opposite side of our transversal. I'll kind of highlight what our transversal is. They're on opposite, so I know they're alternate, and they're on the outside of our parallel lines. So these would be alternate exterior angles. All right, 2 and 6. Again, opposite sides of the transversal, but they're inside my 2 parallel lines. So these would be alternate interior. Okay, 6 and 8. Those are on the same spot, but on different lines. So those are corresponding. 4 and 6. Okay, those are vertical angles, which are also congruent. Okay, and vertical angles are from one of our previous videos. Okay, 2 and 7. Those add up to 180. So we could call those a linear pair, or we could call them supplementary. For this, let's call them supplementary. But they are also known as a linear pair. All right, so now if I'm going to say that angle 7 is 107 degrees, let's figure out all the other angles, okay? Remember, we can find half of our angles without doing any math, okay? I can find angle 1. Remember we said vertical angles are congruent. And then we have alternate interior angles. That would be 3, so I know 3 is 107. I could also say that corresponding angles with 1 and 3. With 5, again, those are corresponding angles. 7 and 5, those are corresponding angles, so I know that's 107. And we obviously know 7 is 107. So now let's find our other angles. We need to know that 7 and 8 add up to 180 degrees. So to find angle 8, which I don't have written, it's just 180 minus 107, which is 73. So 8 and 2 are vertical angles, which means they're congruent. So 2 is 73. Okay, 2 and 4 are corresponding. So that means 4 is 73. If I was looking at 8 and 6, those are corresponding angles. And so again, 73. So a problem like this could look a little intimidating, but we have all the tools to find these. All right, our next one, the type of angles these are alternate because they're on opposite sides, and they're inside of my two parallel lines. So they're inside these red lines. And so we know that those are the same angle. So I'm going to say 8x minus 34 equals to 5x plus 2, because those are going to be congruent. So that means these must equal each other. So to solve, I'm going to subtract 5x and then add 34. And then when we divide by 3, we can find what x equals. Now, if we wanted to, we could actually find what that angle is. Since I know that x is 12, I can just plug in 12 for my x. So I can say 5 times 12 plus 2, and it's 62. Now we should get the same answer over here if I plugged it in. 8 times 12 minus 34, and I get 62. All right, and that's actually all that I've got for you guys today. So we talked a lot about just definitions of corresponding angles, alternate interior angles, and alternate exterior angles. Okay, and remember, when we've got two parallel lines, big angles are the same as big angles. Small are the same with small. All of the BS adds up to 180. So no matter where you are, the B's and the S's add up to 180.